Hi, everyone. My name is Max. I usually go by Max, not the full name. I'm co-founder and CTO of Telmai. What we do, we are building software, data quality, and data observability with a focus on data lakes with the goal of providing the rich context about the quality of the data for humans or for agents to make their decisions and automating their decisions based on the trusted data. Pretty much, it's a layer on top of the data quality and observability. I was lucky enough to work in many startups, and I saw the growth of from very tiny to a unicorn several times. And these learnings actually contributing to this talk today, to the presentation, like when you slap something quickly and how it evolved over time to power a large organization, what kind of considerations you have to make not to fail, basically. This slide is very simple. I don't want to give any examples of how bad the impact of the bad data could be, but pretty much it sums it up that if you are reactive on the bad data, if you're only fixing it post factum, you will be leaving that picture. It will never end. You will always be struggling. You will always be trying to fix it, and it will be too late. So how can we improve the situation? How we can prevent the bad data from impacting the downstream workloads? Here is classic write, audit, publish pattern. Not related to Iceberg yet. The idea is very simple. We've been doing this forever. You write your data into the staging. Then you run your audit logic in staging. Your applications are still consuming data from the main, from the production table. And if audits pass, if they're good, we will merge this data back into main. But with the Iceberg and the rich metadata system of Iceberg, this pattern is very appealing. The problem with having the staging table and moving the data is the fact that you actually have to copy the data. You have to move it. Things break in the middle. You get in a partial state. You have to repair it. There's a lot of challenges and complication for that. So forgive me, you've probably already seen this picture. It's taken directly from the Iceberg website. This is the layers of the metadata. I'm just doing a recap so we can kind of base the next conversation on top of that. So at the bottom, we have the data files. Think of this Parquet. Then the manifest file, which points to them. Then the manifest list, which points to the multiple of these manifest files. And on top, we have the metadata with the snapshots, which allows us to do the time travel with the Iceberg. So we can point to a previous snapshot and read the data as of previous state. Same with branching now, right? So the branch can point to a particular snapshot. And when you create a branch, you start writing data to that new branch. You can operate and read data from that branch like a state of a table. And when you are good, when you're ready to merge, you perform a simple instant metadata operation, fast forward merge, data goes to main. Now all your applications instantly start reading actual fresh data. So here we are adopting the WAP pattern using the Iceberg, right? So initially we will create a new audit branch, then we will write data into this audit branch, and finally, if everything passes, publish this into main. Benefits, obviously, as I pointed, this is all metadata-driven operations. There is no copying happening. It's instant. It's atomic. You can roll back if things in audit didn't pass, no damage to your main table. I will run very quickly through this example. In a code, we are just writing data, validating. In this case, we are detecting transactions which have negative sales amount, audit didn't pass, or audit pass. We're either merging data or not. So the good stuff about this flow is now we guaranteed that all our applications are consuming good data to the point of whatever quality checks we had in there. Not necessarily it was complete enough. When we merged, it was an atomic operation. Either it happened or not. There was no partial state. But the bad things about this, we increased the complexity of this whole process. Instead of simply inserting data into the table, now we have to do orchestration. We have to create a branch. We have to write the data into that branch. We have to run the audit and then merge finally. But the other challenge, it's more of the maturity of the whole concept still. Not a lot of catalogs support these operations. Not a lot of catalogs offer branching. Some of offering partially, like you can read, but you cannot write. So this is still an evolving technology, but I can already say that being a data quality vendor, we see a lot of pull from the market. People get really excited about the whole concept of branching. And as soon as it gets more stabilized and it gets more refined, I can see the adoption ramping up very quickly. So we have the good, the bad, and a little bit ugly, right? It's not about Tom Hanks, though. It's about the problem. When we added the step of auditing data, what eventually happened is, if everything is good, this step is automatic, data got merged instantly. But what if not? We basically added a manual intervention step where the human has to go in, validate the data, and perform actions, repair actions, rollback actions. Something has to be done. That means your delivery SLAs on the data are going to be impacted. You have a human who has to come in, do something. Takes time. You have to have a proper notification system, pager duty, whatever, to get this done. So with our customers, we have improved that pattern somewhat. Even before the Iceberg branches, sometimes it's referred as data binning, sometimes it's referred as something else. But the idea behind that, we don't want to block the data, which is guaranteed to not be perfect. There's always something bad in the data. We are letting the good data flow. We are separating the bad data on the fly as the audit phase is going into the, call it dead letter table, dead letter queue, whatever. A table which collects the bad records for the further analysis. But the good data flows, goes into the audit. Audit has a much higher chances to pass, and data goes into the production table. What it means is you don't block data on tiny amount of bad records. You let the good flow, and people don't have to come in and fix it. There's no this constant pager duty alerting. How it works is very simple. First step is identical to VAP with Iceberg. Second step is we are separating data from the audit branch into the special table. The good records go to the valid branch, another branch. We still do the audit. The audit is still important, but we're doing audit on the clean data now, on the data which was filtered by our data quality checks. Why? Because maybe too many records got separated. The volume is not enough to be considered a good upload. Maybe there was something not covered by data quality rules. It could be some anomalies which usually data observability picks up, such as the ranges of the values got mixed up. The format of the date is now very different. Things which you usually don't write rules for, and data observability systems take care of using their AI systems. And if audit pass, we merge it into main, right? So effectively, it's the same thing with an added step of separating good records from the bad records and continuing the flow. As a result, we are greatly reducing the chances of blocking the data to be published into the main. We are automatically handling significant amount of errors, records not passing data quality rules. But the bad side, again, we even further increase the complexity. Now we have even more steps in this pipeline, more branches. So at this point, you should very carefully plan how to implement it. Bring in the right tooling, bring in the right automation, workflow automation, airflow, whatnot, to make sure you're not doing this in a fragile way. So when we are going now, like this was a simple concept, right? You can code up your audit easily, use SQL or some open source tool. But if you are trying to productize it, there are several more considerations. Well, first, as I mentioned, try to automate the workflows. These steps, they have to be automated. Second is, it's never a good idea to have data engineers to own these data quality checks, unless your company is like 2 people in a garage. Why? Because people who own the definitions of the business logic, they don't want to deal with all the complexity coding and other stuff. It has to be decoupled. It has to be separated. And usually there are business users like data analysts who can write a query, who know how the data should look like. Third part is proactive alerting. When the audit, even though now we have the step which is separating data, good and bad records, there is still an audit phase for major items. And when this fails, you still need to have a proactive alerting. It has to deliver a message with the right context, with the right content to you, into your Slack, into your PagerDuty, whatever. But it has to happen proactively. Like, it cannot sit and wait for someone accidentally discover it. And finally, the incident management. All this context with a little bit of magic dust of AI can be brought into the ticket, let's say in Jira, with the root cause analysis performed by AI, with all the connected dots, like based on the lineage, what else is impacted, what downstreams are affected, create a ticket, and now we can have, or we can call it a production system where you can start talking about the SLAs of the data delivery. So this is an example how we in Telmy adopted this DevOps pattern. Our job is to come in and perform the analysis of the data. Wherever this data is, most likely it's an iceberg. The Airflow pipeline that customer runs on their side, they would create the branch, they would manage that part, they still have to create the branch, write data into the audit. Then they would trigger the API from Telmy, which will launch the Spark pipeline. That Spark pipeline does a bunch of things. So it starts with profiling to generate the view of the data and metrics needed to analyze. Then it does anomaly detection based on these metrics. As a result, to find unexpected anomalies. Then it would apply data quality rules that users defined, the business users defined. Then perform the data binning, splitting good and bad data as producing kind of the smaller chunk of data. And finally, be responsible for creating incidents, tickets, and firing alerts. Once this step finishes, the next Airflow step checks the output. What was the findings in this Spark pipeline? And if everything is good, audit pass, we can merge into main, right? The Airflow does it. So in summary, the benefits of using WAP with Iceberg is that it's a safe and atomic flow, right? We are not creating consistency issues by creating yet another copy of the data. We are not locking tables. We can deliver the data faster into the applications. Data binning helps a lot with that. So we have customers who have implemented and have been running this for production for over a year now, which helps them, especially for data providers. This is very important because for them, having the bad data is a big reputational risk. But the one point which I want to make is data quality gets very complex very quickly. So with WAP pattern or not, try to think holistically where you want to be and invest in a good tooling. Start building either using open source tools or you want to buy tools, but it's rarely successful if you just do homegrown pure SQL type of checks. You will outgrow it very quickly, and ask me how I know, but please consider that. And to summarize, another item is the WAP on Iceberg, the whole branching model. It is still, there are good implementation for that, and for example, Nessie catalog would support that, so Dremio would work fine, but other catalogs may not. That creates another challenge, because you can have tools and systems in your ecosystem as an enterprise which require, let's say, something else, some other catalog. They run on Unity or maybe on Hive, but you still want to leverage WAP pattern with branching. So that creates a disconnect. You should not register the same table in two different catalog systems. You can try to use federation feature. But yeah, please be mindful of that. Things are developing very quickly, and I'm sure like in a couple of months, we will have a better solution and these things will stabilize. But this is what it is now, right? If you think that the WAP is the right thing for you, also please consider on which catalog you are, what else you have in the ecosystem, to make sure you don't run into the problems later. That wraps my presentation. Any questions? Yeah, please. Yes. Yeah.
Is this sort of a version control but for data?
You can think of this way. It's like, yeah, it's branches like in Git. Mm-hmm. Yeah. Yeah.
And then who sets these rules? So let's say you have a branch that the data is coming from a data lake. Who sets these rules to differentiate between bad data? Is it a data engineer?
Yeah. Ideal, it's not data engineer. Data engineers shouldn't be involved in that. That's not their job. Their job to build the infrastructure and make the pipeline work. Ideally, it's business owners of the data. Typically in a larger organization, what we see is there is a core data engineering team, which is responsible for like plumbing and building the infrastructure. But then there are business teams who own different data assets, and they know what kind of checks have to be performed on these data assets. An example in sales transactions is like invoice date shouldn't be too far from transaction date, for example. Data engineer cannot know such things. Yes, and that's why I made the point that these things have to be decoupled. Like it cannot be part of the same configuration of the system. Two different personas operating it. Yes, please. I would try to force it. Like, yeah, I would. Again, honestly, I don't know how it will work because we haven't run a highly concurrent experiment on that. That's why it would be safe to just try to protect that, like through some kind of queuing or some sort of layer. And again, the whole branching concept itself is also still evolving. Maybe we will end up. Another thing which I forgot to mention. One aspect you have to be mindful is when you do audit, you actually may have checks across multiple tables. So the branching has to consider multiple tables too. There you have to, maybe you're doing foreign key constraints, right? That's another consideration. So it's a little bit involved. Yes, please. Mm-hmm. It really kind of on an individual basis. Different catalogs means different things. Some, I know, have like straight don't care, like is there a branch or not, they just return main. Some would, I believe Unity would throw an exception, like this feature is not supported yet. Some can read from the branch, but cannot write into the branch. You have to experiment at this point. Yes, please. Can you repeat, please? I barely hear. Yeah, different anomalies. Some anomalies require the whole data analysis, but most time it's just that portion of the fresh data which came in. Because these are anomalies like about the format of the data. You don't have to scan the whole thing. But there are cases when you have to do like a full group by on the table. Any other questions? All right. Thank you so much.
Thank you so much, Maxim.